this next equation, in fact, all these separable differential equations, we have the same goal, which is try to get all the y's on the left, all the x's on the right, and then integrate both sides to try to, and then isolate the y. Here it might seem like it's going to be more work, or it might not be quite clear just the first glance how to separate the x's and the y's in this problem when I have e raised to the x minus y. How am I going to separate out the x and the y when they're both together up there in that exponent? So just a reminder, this problem you used to know how to do. If I had 3 to the 10th, and I was going to divide by 3 to the 3rd, that's 3 to the 10 minus 3, which is 3 to the 7th. So once you see that example, you can think about this base with an exponent that's a difference. We're going to rewrite it as a division. So this could be my first step here, is to write dy dx equals e to the x over e to the y. So I'm going to go to the whiteboard to do this problem so you can see the flow. All right, so here's my plan here. I'm going to imagine multiplying both sides by dx. So I have the dx over on the right-hand side now. Only thing on the left-hand side is dy. And I'm going to do what I just showed you, which is rewrite e to the x minus y as a quotient. So it's going to be e to the x over e to the y. Now I want to do whatever it takes to get the e to the y over to the other side. So I'm going to multiply both sides by e to the y. So now I have everything on the left is the stuff that has y's in it. Everything on the right is the stuff that has x's in it. Notice dy and dx are both factors. They're in my product. You don't ever want to let the dy or the dx get into the denominator. That's a sign something's gone wrong. And now I'm going to integrate both sides. That's my plan. So I'm just going to imagine slapping an integral on both sides. Zoop, zoop. And these antiderivatives aren't so bad, right? So the antiderivative of e to the y with respect to y is e to the y. The antiderivative of e to the x is e to the x. I'm going to remember my constant of integration, which in this case, when I'm solving a separable differential equation, I only need to put on one side. So I have my plus c on the right-hand side. I have two things left to do. I'm going to have to figure out what c is using my initial value. I'm going to have to figure out a way to isolate y. All right, so this is where I ended up. I know that x equals 0 or y equals 2 when x equals 0. So I'm going to jump from here all the way over here. I'm going to replace y with 2 and x with 0. E to the 0 is 1. So I'm going to isolate c by subtracting 1 from both sides. And I get c is equal to e squared minus 1. I'm going to import this back into that equation. And where we go. So now you can see this plus c I've replaced with e squared minus 1. And my goal still now, we're going to try to figure out a way to isolate y. So e squared is just a number. It's like 2.718 squared. So don't worry about the fact that it looks like it might be a variable. E is a constant, so e squared is a constant. And how do I rescue, if I'm trying to undo an exponent, in this case the y is in the exponent, right? And I want to undo that. We undo exponents with logarithms. I'm going to take the log base e of both sides. Log base e we denote with ln, so natural log. I'm going to take the natural log of both sides. The natural log of e to the y is just y. Having a base of e with an exponent and taking the natural log undo each other. So it's like this natural log and this e just cancel each other out, right? And leave us behind y. And on the other side, the natural log of e to the x plus e squared minus 1. So the final answer. You might ask, do I need to write a domain statement? Well, I need to write a domain statement if the domain of my solution function is not all real numbers. But check this out. So natural log, I can take the natural log of positive numbers only. Well, e to the x is positive because it's a positive number raised to an exponent. E squared is like 2.78 to the second power is like 8. And this is minus 1. So like about 8 minus 1 is 7. I'm going to add 7 to a positive number. There's no value of x that would make that inside negative. So there's no need to give a domain statement because whatever's inside that natural log parentheses is always going to be positive.